All right, welcome back. My name still remains Mr. Pascal, Maths Digest. Today we are looking at the topic that says difference of two squares and sum of two squares. Okay, in mathematics, when you talk about difference, you simply mean a number that subtracts another number, or you subtract something from something. Okay, and when you talk about square, it means a particular number multiplying itself. Okay, now simply we can say the difference of 5 minus 3 will give us 2. Okay, and when you say square, you can say maybe 4 squared, which is 4 times 4, which this will give us 16. Okay, so this is simply what we mean by difference and square. Okay, now if you have x squared minus y squared, this simply will give us a perfect explanation of this difference of two square, in the sense that we can say that this the factor of this is simply saying x plus y, x minus y. This is what we mean by difference of two squares. Okay, now if you multiply this back, remember these are the factors of this. If you multiply them back, you're arriving at this. Quickly, let's do that. This times this is x squared, this times this is minus x y, and this times this is plus x y, and this times this is minus y squared. Now you see that this cancels each other, and we have 2 x squared y squared back. So this returns us back to the original expression. Okay, now coming to the sum of two squares. Remember, sum is just adding a number to another number. You can say 5 plus 5, which is 10. And when you say square of 5, just like we have here for 4, we say 5 times 5, which is 25. So this will give us 25. Now, but since we have a difference of two squares, sum of two squares doesn't have no what factor. It has no factor, just like this. Rather, x when you see this, this means not equal to. Okay, this sign means not equal to. This cannot give us x what this simply means that this cannot give us this. All right, factorize the following: a squared minus 9, and the second one is 16x squared minus 9y squared. Solution: the first one, a squared minus 9. This will give us, remember, is a difference of two squares. Okay, so we can say you see, remember what we said about square of a number. Now let's think about a number that when you square it, you get 9. And that number is what? Simply 3. Simply 3. So you look at the quotient of this number, that's the power of this number, of this a. You try to find something that when you raise it to power of the same number here, you get what you have here, and that we have what? 3. So 3 raised to power 2 is what? 9. Okay, now with this we can say equal to, if you remember what we did, that x squared minus y squared equal to x plus y in bracket x minus y again. Okay, now when you look at this, this is exactly what we're going to do here. Now we say a plus 3 in brackets a minus 3. So with this now we are done. So these are the factors of this expression. Okay, now for the second one we have so with this now if you look at the coefficient of x and y here, they are more than what? They are what? More than 1. Okay, with this, what we do is we find a number that when you raise it to power 2, so that it can suit with this, okay? When you raise it to power 2, it will give you 16. And a number, when you raise it to power 2, you get what? 9. And those numbers can be what? 4 raised to power 2 minus 3 squared raised to, okay, it's 3 squared y squared. Okay, so these are the numbers. Okay, now with this we can still return it down to this, and with this we have equal to difference of 2 square. Okay, so now this is what we have. Okay, and with this I think this is the answer. I just asked to find the factors, factorize the following. Okay, so at this point these are what we can have as the factors of these expressions respectively. Okay, I believe that's not hard. If there's any questions, still ask us so that we can explain further. Okay, right, now we're going to take sum and difference of 2 cubes. Remember, sum of 2 squares doesn't have any factor, okay, as we explained earlier. So let's take the example on the sum and difference of 2 cubes. Thank you. All right, when you talk about sum and difference of two cubes, if you have x cubed plus y cubed, this will give you x plus y in brackets. Another bracket, you have x squared minus xy plus y squared. Okay, now if you expand this, you are arriving back at this. Can we do that quickly? Okay, x times this, x times x squared will give you x cubed. X times this will give you minus x squared y. X times this will give you plus x y squared. Okay, now we come for this. This multiply this will give you plus x squared y, and this multiply this will equally give you minus x y squared, and this multiply this will give you plus y cube. Okay, now if you look at this now, you find out that there are some that are like terms among them. Okay, now if you fish them out, if you check the one of this x squared y, you find out that this particular one has negative, while this one has what? Positive. So you can cancel for this. Okay, now you come to this as well. This has minus plus, while this one has minus, so they can cancel each other. You are returning back to x cubed plus y cube. Okay, so you return us back to this. Okay, this is some example of it. Now, if you come for x cube minus y cube, okay, this quickly will give us x minus y in brackets x squared plus xy plus y squared. Okay, ladies and gentlemen, if we expand it as we did here, we are going to get back to this. Can we do that quickly? All right, this times this will give you s cubed. This times this will give you plus x squared y. This times this will give you plus xy squared. Now, if you come for this second one, you have minus y times this, we have minus x squared y. Minus y times this, we have minus xy squared. And minus y times this, we have minus y cube. Okay? Now, let's also identify the like terms among them. Now, with this, we have this has positive here. And if you check the other second of it, you have negative. So this we cancel this. Okay? Now, if you look at these two, we have plus xy squared and minus xy squared. So they cancel each other. If you look at this, you return back to where you started from. Do we understand that? Thank you very much. These are the example we can take for what's sum and difference of two cubes. We have the first one is a cube plus 64y cube. That's raised to power 3, okay? Now we can equally have 125 x raised to power 3 minus 1. All right, the first one. Okay, for this, if you look at this, we have 64. Okay, so like we know, we are going to what? First of all, find something that when you raise to power 3, okay, you will get 64. Quickly, we can have that to be 4. Because 4 times 4 times 4. This is 16. And 16 times 4 will give you 64. Okay. Now with this, we can go ahead and remember what we explained earlier about the cubes. Okay. Difference of the two. All right. Sum of two cubes. The first one. All right. Now with this, we can go. In bracket, we have okay. So this is what we are where we can represent it. With this now we can go. We further say that a plus 4y in brackets a squared minus 4ay plus 4 times 4 times 4 for this 2 here, we have 16. And we return y squared. That's y raised to power 2 is what? Y squared. Okay? All right, now with this, this is the end of it. Okay, yeah. Okay, now number 2. Number 2, we have 125 x cubed minus 1. Okay, now I want you to pay attention here. There's a little trick we're going to do here because of this 1. I want to remind us that whenever you have 1 and you raise it to power 100, it still remains 1. If you raise it to power 1000, it still remains 1. Okay? Now, let it not get you confused at this stage, okay, because of 1 we have here. Now, what we do is this. We simply look for a number of which when you raise it to power 3, you have 125. And that number is what? 5. So this is exactly what we have here. Okay. Now for this 1, we can, because of the power of these numbers here, or the variables here, we have raised to power 3. So we can equally say 1 raised to power 3, because 1 raised to power 3 is still what? 1. So this and this is still the same thing. Okay. Now we go further. We say difference of 2 squares. Okay, so this is the expression for this. Okay, now pay attention. Okay, now we have 5x minus 1. Here we have 5 raised to power 2 is what? 25. 25x squared. Okay, plus 1 times 5 is still 5. 5x, and we have plus what? Plus 1 raised to power itself is still 1. Okay, now we have this. This is the final answer. Okay, thank you. If there's any question, feel free to ask. Okay, right.